Here is a program that I've created in G-code, and I'm going to use it as a demonstration of how you can make G-coding easier. The program itself is a single pocket, but in fact I'm using it to create a datum face on a small part that might have a problem with a big fly cutter. The whole program is actually cut and pasted from a variety of other programs I've already created, which already have all the extensive commenting, as you can see. And we'll jump in here. Here's the core of the program. It starts here and goes down to here. And that's actually a pocketing program, but not all of the pocketing program. Now, if you were using conversational mode from Heidenhain and got locked into their proprietary format, every one of these parameters it's asking for would be prompted for in plain language. G-code, the way they've set up the G-code doesn't do that. So what I've done over here in the comments is I've put all of the calls that it needs to have in the comment. Now here it only needs one. What it's going to do is over here only call subprogram 10. These other one, it can do a total of calls to 12 subprograms. Some of them are pockets that go over the existing pocket and extend it. Others will be islands. We're not using that, just a single pocket. And the program it calls, the subprogram, sorry, is down here, L10. So you can see here what it's calling for this is the perimeter slot that it creates around the path, around the part we're going to create a datum face on. Okay, next thing it does of interest is this call here. This is actually asking for a pre-drilled hole so that your slot drill can drill down without gorging. In fact, you can use the suggested drill up here, but if you do, you might risk clipping down the side of the part you've squared up. So you can either make sure the drill is small enough not to do that, but only needs big enough to do the centre part of the slot drill, where it might have trouble. But you don't know where the machine is actually going to create this pre-drill hole. So for what I'm doing, it's generally better just to leave it out and don't do it, because when it calls up the roughing drill, slot drill here, you just make sure that the perimeter has it only half sitting on the part, the perimeter of the part. In other words, these guys down here are a little bit oversized on the dimensions you want. Okay, so now you can see that this can be quite user-friendly. You see here there's a whole list of parameters it's asking for, P01 to P07. I don't really remember quite what they are, and they tend to change what they mean for different types of calls. So here we have them. P01's the safety distance, P2 the milling depth, and you can see it's only just going to skim a little bit off, and it does it in one peck, pecking depth. No, sorry, it's half a millimetre, so it's going to do it in 4. And it works all that out for you. You don't have to worry about that. Okay. Further down here, there's usually a call for a finishing tool, and I've just left that out because all it does is it takes a little bit of milling allowance off the perimeter, which in this case doesn't exist. Okay, now up here is the tool definitions. Okay, and they come from a set of tools I had set up at the time, and I don't use them all. But you might as well just cut and paste them in. So it's only going to use maybe the drill and this roughing tool. That's only going to call these two up, and you can either run fast through the process it does for the drilling, or leave the drill out or whatever. Okay, so that again tells you what all these are. The length relative to the tool 0. In this one, the case is my tool 0 because I've set it at length 1, and it's a 5mm drill. Up here we've got another block that's just cut and pasted. Of course, you go in and change the actual numbers depending on the size of the part you're using. And this is for the 155 rather than the 151 TNC, and it's capable of doing a graphic display so you can see what the K-path is going to be. And it's saying G30 is asking for the lower left corner of this graphic block, a blank. G17 says, okay, I'm telling the graphics that the cutter is going to be in the Z-axis. And here's the lower left and X and Y position, X, Y and Z positions. This guy here, 31, is asking for upper right, absolute dimensions. I think you have to use them, you can't use incremental. And there it is at the top right, X, Y, Z. So there, usually, I make a bit bigger than the part itself, so I can see the cutter coming in from a distance outside the part. Otherwise, it just suddenly turns up. This up here is to do with the Heidenhain being able to be put on multiple different types of machine, and so they don't have defaults for a lot of the initial values, and there's 4 groups of them, and you pick one out of each of those groups. So this is telling you that the tool's going to be in the Z spin tool holder, spindle. This is, for the time being, go as fast as you can in every axis, and that is different on each axis on my machine, and it's in the machine parameters. You can limit it to, I think my X and Y are 3,000 millimeters a minute, and the Z is heavier, so it can only do 2,000. G40 don't compensate offsets for the tool, for the time being, and G90 is absolute dimensions. And then there's a little thing that's unique to this machine. The program numbers are pretty simple, 50 in this case, number 50, and it's in metric. G71 on this machine means metric. And down the bottom here is the end of the program. Again, it's a little repeat of that. But the actual program finishes here. A thing with this particular implementation of the language is that if I was to put this subprogram here, and I'm highlighting, up the top, it would run it without it being called as a subprogram. That's a little bit of foible of the language. So I find it better to put it outside the main program, outside here, down below it, so it doesn't get executed unless I ask it to execute. And this subroutine here, if you recall, tells us that for the perimeter of the part I wish to mill. And this subroutine here, you'll note, is called several places through the program, and it's simply to park the tool up the top off to the right, where I can take the tool out by hand. It's just a tool change position that's not particularly critical. Sometimes I change it depending on what's going on with what I'm machining. Okay, so you can see it gets called here and here and here. In this case, it's not asking the tool change, it's just put at the end of the program, it's just putting the tool up in the change position so you can get the part off the table. Okay, so you can see here that the thing basically starts and simply executes its way down through the program, and when it gets to here, it's finished. G38 has stopped the program running, and MO2 has jumped to the start of the program and switched everything that's running off. So you can see that by getting a group of programs together with good commenting, you can actually have just about as much power as if you were doing the Heidenhain conversational thing. But if you happen to have a whole lot of other machines around of different brands, kind of handy to stick with G-code and be sort of standard. Although this G-code is so old that a lot of the numbers are now used for things that are different. Anyway, that is just an introduction to the way I program. As I get smarter, I'll probably get more pedantic about the way I structure these things.